Crazy shit. Fake Oreos. Oreo नहीं है, Ohio है। Actually Ohio exist करता है, क्या है? वो भी Oreo था।
तुझे पता नहीं तो Ohio exist करता है।
ये तो पता है, मैं भी तो बोल रहा हूँ।
वो भी ना,
Ohio brand का एक Oreo है।
नहीं होना। नहीं बता।
Yes. No, actually, I'm like.
और कब तक कितने बजे तक S20 के आसपास कितने तो बजे
में बच्चों को लेना
इधर मिलवाना
हाथ में बच्चों को लेना चाहिए
रिपोर्टिंग टाइम को गर्ल्स क्या ये तो रुक जा उसकी आधी सारी
अरे हाँ वेदांत ने प्लानिंग बाहर निकल के एक बार उस साल पढ़े थे इमेजिन लाइट को आया वाला चैप्टर मुझे लगा है कि डैशबोर्ड में वही लिखा था वो आया वाला चैप्टर डैशबोर्ड में कुछ भी लिखा होता है बट उसमें ये डैशबोर्ड में ना कुछ भी लिखा रहता है
अगर मैं नहीं देखी अरे प्लीज आप पर डूबो देखो के लिए भेजा चाहिए उसके लिए वो चाहिए अभी
There's something special about
ये ले
समझ रहे हैं ना? Yes,
Everyone. Where did we stop in the last class? Huh?
We finished with light. Now we are supposed to start with electricity.
Chapter over? Last?
Yes.
Electricity.
Electricity? Okay, very good.
Can we start with human ions? Can we start with human ions?
How many want human eye? How many want electricity?
Human.
3. Electricity? More. So, human eye, do you have any questions?
It not start. It's in long months.
Okay. So, do you have any questions or doubt? Not yet started.
Not yet.
There are some questions from human
So, okay. Ask. Let me address some questions of this. Then we'll start with electricity. Is it started for you?
No, it not start.
Okay. So only thing in human eye to be understood is the eye defects and its correction.
There are living prism.
Prism. Simple, not much. If you have understood the concept of refraction, then you can understand. What question? No. Question number 5.
From exercise.
Okay. Read that.
A person needs a lens of flower minus 5.5 diameters for correcting his distant vision. For correcting his near vision, we need a lens power of plus 1.5 diopters. What is the focal length of the lens required for correcting first distant vision and the near?
So this is the case of eye defects, like I said. Okay. So is there funda on eye defects clear? So only 2 eye defects are there. One is hypermetropia, and myopia. So what is the defect here? Near side not okay.
Lens for correcting his distant vision.
In hypermetropia, everybody in hypermetropia, which vision is okay, which is not okay? Far vision is okay, near vision is not okay.
Yes.
Okay. So near side is defective. So it has defective near side. Which kind of lens is needed? Convex lens. Here you require convex lens. So correction by convex lens. In this case, far side is defective.
Yes.
And it is corrected using concave lens. Okay, so this is using convex. So this funda is clear, right? Now what is given in the question?
It is given that
Lens power required is
minus
5.5. So what is the defect here? E given is minus 5.5. Okay, so you can find out what is F here, right? Okay, what is F? Okay, and this is in meter. Okay. Now, so how much is in centimeter? So it is 52. How much it will be? 11. So whatever, okay. So this is how much? 5 to 10. Whatever it is. So focal length. So distant vision is defective here. You require a focal length of this. Okay, whatever centimeter comes. For distance vision, this. What about near vision correction?
Median length of plus 1.5 diameter.
So here it is that is equal to 1 upon 1.5. So this is meter. Okay, so either you can write the answer in meter or centimeter. So this is the correct, just pure use of,
Conversion.
it's just conversion, right? Here also it is 1000 by 15 centimeter. This is the answer. So you have to only calculate focal length. Okay, that's it. In this you have to only calculate focal length. So in meters, the answer will be like minus 1.8.
Yes. That is now
And
for the first one and for the second one.
Second is 0.6.
0.6.
Okay, so you can calculate either in centimeter or meter. Shall we go ahead? See, we'll do it more properly when we do because there are ray diagrams to be understood how the correction takes place and why. Yeah. But from the sign you can take out power is negative as it has to be. Which lens? Concave. Negative focal length. Power is positive, then it has to be convex lens. Okay? Strong sign. All right. So don't feel that some injustice is being done. Feel free to ask questions. अगर स्कूल में तो अभी पढ़ाएंगे नहीं एक महीने में, तब तक तो I think you will also reach it. Let's start electricity. This is also a big chapter, big weightage. So first of all, what is electricity? So it is a type of energy. It is a most convenient type of energy which we are using today. Okay? So it is a type of energy. Most convenient form of energy in use today. So we cannot live without electricity. We don't burn wood to cook our food today, right? So we have different alternate form of electricity, energy. This is one of them. So when we use electricity, what do we use? There has to be source of electricity,
Yes.
right? So source means electricity in stored form, right? So how do we store electricity? In cell, okay? We store electricity in cell, right? So right now, what we are going to learn about stored electricity is only in the form of cell. So source of electrical energy is cells and batteries. Cell and battery. What is the difference between cell and battery?
Battery is a collection of multiple cells.
Correct. So cell is individual. This is the symbol of cell. Okay, and battery has multiple cells connected together. If you need more energy, then you require to connect multiple cells together.
But more energy or more potential?
So what is potential difference?
So basically, a cell creates a potential difference.
So what is potential difference? Potential, have you heard about kinetic and potential energy?
Yes.
So this is electric potential energy is potential difference. When the energy is stored, it has to be stored in the form of potential. That's why the word potential. Got it? So cell has potential difference, means it has electric potential energy. Got it? Okay. So it has what is called as potential difference. Potential difference means what? The plus sign means these are basically cell has got, see what is cell structure? देखो cell में क्या होता है? This is the basic diagram of cell. What does cell consist of? It consists of electrolyte and it consists of electrode. What is it? Electrode. So electrodes में समझो you have copper and zinc, let us say for example. Different cells will have different combination of electrodes and electrolyte. And what is electrolyte? It is dilute acid. Okay. So let us say you have H2SO4 diluted. So when it is diluted, right, then it will be in the form of ions. Okay, this is diluted acid. Means mixed with water. When acid is mixed with water, the H2 and SO4 ions will be formed. So this become a conducting solution. But what is copper? It has tendency to lose electron easily. Okay, right? So H2 plus plus. Say let's say you have H2 plus plus. So in this you have H2 plus plus, and you also have SO4 minus minus. Okay. Now what will take place? Copper has a tendency to easily lose electron. So it loses electron. Initially it has equal number of positive and negative charges. Now when it loses electrons, 2 electrons are lost here. So it will develop positive charge here. Okay? That means a chemical reaction taking place between copper and hydrogen. And then it receives electron, it becomes hydrogen gas and it comes out. Right? Now, likewise, SO4 reacts with this and it deposits 2 electrons on zinc. So chemical reaction has started. That will go on. It will go on till certain equilibrium is reached. Okay? It will go on. So now, the one which is developing positive charge, that is said to be at higher potential. The electrode that develops negative charge is said to be at lower potential. So this is now high potential and this is at low potential. Will this reaction keep on happening? No. It will have sufficient positive charge developed. Now it will repel further H2++ coming to react. That is the equilibrium stage. So at equilibrium stage, there is some potential difference between the terminals of the cell. So when you buy a cell from the market, you buy it at certain potential difference between its terminals, right? Now you got to use the cell. Now you have the cell. So everybody has seen cell, right? It's something like this. So this thing is positive. It is at positive charge and the base is negative charge. So this is one electrode, it's like this. Inside the cell, if you get the opportunity to break it, any old cell. So this is one terminal. Then the electrolyte is filled here. It is dipped in electrolyte. This is electrolyte. The red part that you see is electrolyte. Okay. So, and the cover, the outer covering, that is the other electrode. The case of the cell itself is the other electrode. One is this electrode, which is positive, and negative is the case of the cell. Understood? then it is packaged from outside. Okay. So now if you have to connect it with some wire, okay, you have to connect it with some wire. So what do you connect now? This is how you will connect. यहाँ पे बल्ब लगा. So what do you do? You connect the bulb with the help of two wires. Okay, and this is plug, key or switch. Right? What do you have here? Plug, key. These are conducting wires. So always you have a pair of wire, right? So once the cell which has potential difference, right, it will begin the electric current to flow through the cell. If the cell has filament, so current will pass through the filament, and this is how circuit will be completed when the key is closed. This is called plug key. Key is like switch. Only when this dot, if this dot is not there, that means switch is open or switch is off. Now when you put or switch on the key, now the circuit is complete. So this is called electric circuit. So what does the electric circuit consist of? It consists of source of electrical energy, cell, then it requires connecting wires and the electrical appliance, which is called load, electrical load. Okay, load is something which will require electrical energy to operate. So simplest is electric bulb. So many loads you see: fan, tube light, okay, camera, television. All of this is electrical load because it is working on electrical energy. But the energy is not in the form the way it is in cell. We are using alternating current, AC. यहाँ पे क्या है cell में DC है, direct current. Okay, so we'll come to AC later. What is the difference between AC and DC? Direct current में the direction of flow is only in one direction, like this. AC is not like that. AC goes first in one direction. If you draw the graph of AC and DC with time, so DC current always flow in one direction. This is the symbol for current, I. So with time, it has a fixed value. Once you switch on, once the current is established in the circuit, it will be of constant value and it will flow in one direction. Whereas alternating current flows like this. It doesn't have a fixed value. It increases, reaches a maximum value, then changes direction, reaches the maximum value. So it goes alternate. So half the time it is positive, half the time it is negative. That way. That's why it is termed as alternating current. Okay. So this is the form of AC current. So in our house, right now, whatever we are using here, that is AC. And the potential difference is represented by V. Potential difference is represented by V. And its unit is volt. So in house, we get 220 volt. The supply that we get in our house is 220 volts and 50 hertz. Means it has cycles. So there are 50 cycles in 1 second. The supply at our home has 50 hertz cycles. Got it? So to describe any electrical energy source, we need to mention its potential difference. Okay? So higher the potential difference, more work capability it has. Okay, to run this high load, high electrical load, you require AC energy. You can't run it with a battery. And the cells that you get in the market are generally starting from 1.5 volt. So when you take two cells, 1.5 plus 1.5 will be 3. They are in the multiple of 3, 6, 12. So if you are using inverter battery at your home, it will be mostly 12 volt. Okay, is that clear? So with cell, you can only energize or operate low power devices whose energy needs are less. So like in a torch, how do you operate a torch? You put a cell, a wall clock to tick, the hour, minute, second hands are ticking. That is using cell. Tube light depends. So different appliances are designed for different electrical source. So it can work with AC power, then it won't work with cell. But you can work by using inverter. So inverter is a device which converts the DC power into AC power. Okay? So you use as input supply as cells or batteries, then you use a device called inverter, which generates power in this form. Input power like this, output power like this. Then you can power your devices. Okay? So source of electrical energy, cells and battery, and then we have understood what is potential difference. So high potential is, you can think of it like electrical energy with higher pressure, high pressure. Like for example, think of a pipe. Okay. Let's say this is a pipe, and these are two water tanks with some tap here. Okay. So if the water levels are same, will there be any water flow?
No.
No. So it is like same level means same potential difference. Okay. So for the water to flow, there has to be some difference. Right? So let's say here the more water is filled. Now when you turn on the tap, then there will be water flowing this direction. Till both levels are equalized. After that again it will not flow. Okay? So this is like, can you use a cell, once you bought a cell from a market, can you use it for your lifetime? No. So what is happening? Cell has this ability to react with the electrolyte. Electrode and electrolyte will react. तो अभी होगा क्या देखो? Suppose you had 1, 2, 3, 4, 5, 6 charges for simplicity. This is the equilibrium stage of the cell, right? Now what you are doing, you are connecting outside some electric cell, some electric bulb. Okay. Now this wire has lot of, this is a connecting wire. Connecting wire, what is it? It is an electric conductor. So it will have lot of free charges, electrons, right? So now what will happen? It has a lot of electrons, so it will push the electron in this direction. So electrons are everywhere. Now this will repel electron. तो ये electron क्या करेगा अभी? ऐसे घूमना शुरू होगा. When you close the switch. Okay, this is another symbol for key. Now when you close the switch, okay, when you close it, this electron will come here. And now it will neutralize this. Correct? So this electron actually goes from here to here and reduces one positive charge. So is the equilibrium disturbed now? What was the ability? 6 electron and 6 protons. Now once the equilibrium is disturbed, it will immediately react again. Right? So there are two things. One is equilibrium condition. You might study in your chemistry. So every chemical reaction has an equilibrium state. After reaching equilibrium state, the reaction will stop. Then it also has a lifetime. Once the chemical reaction has reached its lifetime, then it will stop reacting after that. Okay. So once the equilibrium is disturbed, again it will react and maintain the charge again, 6. So the charge is being picked up from the electrolyte and the current is flowing in the circuit. Now, electron is flowing in this direction, but conventional current direction is taken as opposite to the direction of electron flow. By convention, because always water flows from higher level to lower level, high to low. Okay? In reality, we always see natural phenomena taking place from higher level to lower. But in electricity, it is the opposite. Opposite charges attract each other. So electron is flowing from low potential to high potential. Actually, the current is because of flow of charges. But to make it consistent with the other observed phenomena, we have devised the concept of conventional current. So this is just a sign convention, just like your plus minus. So by convention, we say that the conventional current flows from positive to negative. It is just an adopted convention, but actually the electron flow from negative to positive. Is that clear? Positive charges cannot move because they are fixed ions in the solid. What moves is only the loosely bonded valence electron in the last shell. So the free electron is free to move only inside the conductor. Okay, but it is going from parent atom to next atom to next atom likewise. Is that clear? Now, so is this understood? High to low, and why this is not low to high but high to low. This is by convention in electricity. So is this clear? Once the equilibrium is disturbed, the potential difference will be maintained by the electrolyte as long as it is within its lifetime of reacting abilities. Okay? तो ये चलता रहेगा. तो ये कब तक करंट लेगा? जब तक इसमें reacting ability is remaining. But you will see that after few months, the light becomes dimmer. That means it is not able to resupply the charges on the electrode. So what do you do now? Either you replace the cell or use a rechargeable cell. So there are reactions of both types, reversible and irreversible. So if your electrolyte obeys irreversible reaction, then you can charge it like you have cell in your mobile. In 24 hours, mobile needs to be recharged again. Because the electrolyte you have used obeys, it follows reversible reaction. So that's why we have two types of cell, chargeable or single time use. Okay? These are all chemical property of the electrolyte chosen. ये समझ आ गया? So now अब हमको पढ़ना क्या है? If we need current in the circuit, क्या पढ़ लिया हमने? बहुत कुछ पढ़ लिया. So this is electric circuit. So what is electric circuit? It is a continuous and closed current conducting path. Write down. What is electric circuit? Circuit. It is a continuous and closed current conducting path. Current conducting path. Okay, this is electric circuit. So here we have drawn a actual circuit, but while studying we draw what is called as schematic diagram. So the way we draw a schematic diagram is like this. So this is a simple electric circuit. This is cell E, connecting wires. This is your load. So every load has what is called as electric resistance. Okay? So R is resistance. R is load resistance. I have given this for you to understand how the cell functions. Book में नहीं दिया है वो. So this is a concept I have. So high potential is just like high level. Water के केस में ऐसा है. वो higher electric level है. ये electric pressure बोल सकते हैं. जिसकी वजह से कंडक्टर के फ्री इलेक्ट्रॉन्स घूमने लगते हैं. तो पोटेंशियल डिफरेंस के बगैर करंट पॉसिबल नहीं है. So what is AC, what is DC? If you want, you can write down. AC supply, this is AC. This is DC. Okay, what gives DC? Cell. Direct current. DC stands for alternating current. DC stands for direct current.
Sir, I is for current.
Yes, electric current. Huh? What is I? Current, electric current. Just adopt it. I mean, why your name is what your name? Current is because flow, water current. Current is, water is flowing, na? So we say anything flowing is a current. So here charges are flowing. We define current. अभी तक हमने define नहीं किया. I wanted to give you the full perspective. Then we'll go into each pieces. Okay. Right now I just wanted to tell you with the things that are familiar. You are actually using it on a daily basis. Now we are going to understand the underlying principles. Okay. So now we'll understand potential difference. Have you written all this or?
Yes, sir.
Because these are concepts. It will accelerate your learning in a very short space. ये तो तुमको बहुत सारे passages पढ़ने पड़ेंगे, ठीक है? चलो मैं इसको मिटाता हूँ. So why do we need energy for? Why do we need energy for? To do work. Energy is required to do work. As simple as that. So when we have cell, right? What does it have? It has electric potential energy. Cell is the electrical energy in the stored form. So when we are using the cell, what is cell doing? It is working for us. So what is the work of the cell? To move the electron. That is to move the charge. So what is the charge of electron? Difference. Its symbol is B. So look here, what cell is doing? Let's call this 2 points in A and B. Right? Cell is moving the electron from here to here. That means cell is working in moving the electron from here to here. So how do we define potential difference? Potential difference के लिए 2 points चाहिए because the difference is between 2 points. Potential difference between 2 points is defined as work done in moving a unit positive charge between those points. Okay? So it is defined as what is the potential energy? It is equal to the work done in moving a unit positive charge from B to A. Got it? So mathematically, how will you write this? Therefore, potential difference is equal to work done per unit charge. So in moving charge Q, if the work done is W, then in moving unit charge it is W by Q. Okay? Understood? In moving charge Q, let us say the work done in moving the charge Q from B to A, देखो, ऐसे देखो. Let's say this is point A and this is point B. Okay? Let us say in moving charge Q, what is the work done? W. So if charge Q corresponds to work W, therefore unit charge corresponds to W by Q by unitary method, and this by definition is potential. Therefore, V is equal to W by Q. Understood? By unitary method, Q चार्ज मूव करने के लिए A से B में कितना वर्क करता है? W. यूनिट चार्ज के लिए कितना होगा? W by Q. उसी को पोटेंशियल डिफरेंस बोलते हैं बिटवीन दीज टू पॉइंट्स. ठीक है? समझ आ गया? तो अभी हम चार्ज Q क्या है? चार्ज है. Q is the symbol for charge. ठीक है, so लिख लेते हैं where E is potential difference between points A and B. Q is at W. What is W? W is work done in moving charge Q. Q from A to B. ठीक है? तो Q क्या है? चार्ज का सिंबल. तो हम यूनिट लिख लेते हैं सबका. ठीक है? यूनिट B का क्या यूनिट है? वोल्ट्स. चार्ज का क्या यूनिट है? कूलम. ठीक है? W का क्या यूनिट है? जूल. ठीक है? सबका सिंबल क्या है? B, कैपिटल C, कैपिटल A. ठीक है? So therefore, what is 1 volt? Yani when will we say that the potential difference between A and B is 1 volt? When 1 joule of work is done in moving a charge of 1 coulomb from A to B. Sometimes you are asked to define what is 1 volt. So what is 1 volt? It is the work 1 joule of work. When 1 joule of work is done in moving 1 coulomb of charge between any 2 points, then the potential difference between those 2 points will be 1 volt. Okay? So always the potential difference is defined in terms of ability to do work. और यहाँ पे वर्क में हम चार्ज ही मूव कर रहे हैं, ठीक है ना? So you'll get used to it. Right now you're familiar more with mechanical works, जिसमें हम क्या करते हैं? We move a body of mass m by some distance. So force applied to move the body into displacement is work done. तो वहां पे मास को हम किससे रिप्लेस कर रहे हैं? इलेक्ट्रिकल केस में चार्ज. Mass in mechanics is replaced by charge in electricity. ठीक है? ठीक है. So what is define 1 volt? So define 1 volt. Mathematically हमने जो लिखा है उसको इंग्लिश में कैसे लिखेंगे? One is unit positive charge, क्योंकि नीचे. One क्या unit positive. So how do you define 1 volt?
1 volt is work done to move charge from 1 point to another. Volt will be equal to work done to move charge from 1 point to another.
Right now. Potential difference between 2 points. Potential difference between 2 points is said to be 1 volt. Is 1 volt if 1 joule of work is done. If 1 joule of work is done in moving 1 coulomb charge between those 2 points.
So can you repeat?
From where?
Potential difference between 2 points is
Said to be 1 volt when
1 volt where?
when
When?
when 1 joule of work is done. When 1 joule of work is done in moving 1 coulomb of charge. Moving 1 coulomb of charge between those 2 points. ठीक है? So we have done nothing but stated this mathematical expression in words. That's all. Okay. So now next, so what is 1 coulomb of charge? So what is the charge on electron? Write down charge on electron. Charge on electron. What is the charge on electron? It is minus E. and E is given as 1.6 into 10 raised to minus 19 coulomb. Okay. So charge on electron is this much. Okay. So E कितना है? Where E is 1.6 into 10 raised to. इलेक्ट्रॉन पे चार्ज कितना है? माइनस ए. प्रोटॉन पे कितना है? प्लस ए. चार्ज ऑन प्रोटॉन इज प्लस ए. Plus that is plus 1.6 into 10 raised to minus 19. This you should remember. Next, you will define electric current. The symbol is I. It is defined as the rate of flow of charge across the conductor. Okay. So these wires are conductor, the wires that you use. Right? Suppose you have a piece of conductor like this. Now you have connected some cell. Let us say this is the piece of conductor. So when you join some potential difference here, then what will happen? All the electrons will go in this direction. है ना? ये क्या तुम्हारा cross section of the conductor? That's why across. So when you cut the conductor, you will get a cross section like this, circular. So the number of electrons flowing through this. Right? So how is current defined? It is defined as rate of flow of charge. So that is, this is equal to Q by T, or I is equal to Q by T. So capital Q is big charge, small q is less charge. But how much is this charge equal to? Charge is made up of electrons only. So एक इलेक्ट्रॉन तो पास नहीं हो रहा है ना. Let us say some n electrons are passing. N times E. Got it? So many electrons are crossing per unit time. So charge constitutes so many, sum total of how many electrons have passed. So therefore current is Q by T is also equal to NE by. Okay? And what is the unit of current?
Ampere.
Yes. Is ampere. So when do we say that the current is 1 ampere?
Charge to divide by
What is 1 ampere?
1 coulomb charge flows in 1 second.
Each second across the cross section. Means this cross section is anywhere throughout the conductor. Each second, select any cross section. When 1 coulomb of charge is flowing, okay, then the current is said to be 1 ampere. Okay, so write the definition yourself. Write the definition of 1 ampere. You know, when a coulomb of charge flows, across the cross section, of conductor, every second, then current flowing through the conductor is said to be 1 ampere. Okay. So now the next question is, can you tell me the number of electrons that would flow when 1 ampere current is flowing? How many electrons will constitute 1 ampere? Question. How many electrons constitute a current of 1 ampere?
6.6 times 10 to the power of 18. 6.6 times 10 to the power of 18.
So what is current? NE by T. So N is equal to IT by E. So I is 1 ampere, time is 1 second. E is 1.6 into 10 raised to minus 19 coulomb. So this will just give you a number. So how much is this? This is basically 1 by 1.6 into 10 raised to minus 19. So how much is this?
I think 6.6 times 10 to the power of 18.
So 10 to the power 20 by 16. You can write it as 100 into 10 to the power 18. What was 16? So this you would get 6.25, I guess.
No, 6.6.
Is it?
Yes, sir.
Let's check.
Calculator.
Hmm?
Calculator, sir. Google.
ना भी बड़ा कैलकुलेशन नहीं है 4 4 is 16 now divide 25 by 4 4 6 is 24 10 4 2 is 8 so better do the calculation by hand मतलब ठीक है it's 6.25 into 10 raised to 18 electrons that's a large number 10 to the power 18 means billion times billions. It's a humongous number. Each second. Okay, so that current is 1 ampere. So a shock by 1 ampere current is fatal, could be fatal. Okay, so how much current is flowing through your wires here? So it depends on the appliance. If it is geyser, so it will draw close to 10 ampere. Geyser or air conditioner, all high power devices will draw more current. So if you happen to accidentally touch that, it will be fatal shock. Okay? So it's a lot of current. In our body itself, current flows. We are also like, are we not made up of electrons and protons? Every substance is. So are electrons flowing? Yes, all the time. But that magnitude of current in our body is in microampere. It's 1 billion times less than an ampere. Okay? Have you experienced current in your life?
Yes.
So when you take a blanket, okay, like sometimes it makes noise. Okay, so that is also static discharge. Sometimes you may get an annoying feeling like when you're touching in summer weather, when you're opening the door of a car sometimes, or even in malls when you catch the escalator, you feel some shock. Okay, so that's correct. But that discharge quickly dies. But if the potential difference of discharge is maintained, that's when you will continuously shake for a while. That discharge happens suddenly, it's gone. The charge buildup is due to frictional electricity. A lot of people, touch it and go. So due to friction, the charge buildup takes place. Now suddenly you reach there and you touch it, and sometimes the charge flows through your body. That's when you experience that. Now do not go home and start putting finger in the socket. Okay, not a good idea. Because when some people are told, okay, don't put your hands in fire, it will burn. They want to try and test it. Don't listen to the elders. Okay. So are we good till here? Okay, let's. So electric potential and electric potential difference. There is something called electric potential also. What is electric potential? What is potential difference? So it's defined. Let's define what is electric potential. So we said these are the 2 points, okay? So what is the potential? The way it is defined is, let us say you have very far away distance, imaginary. When you are bringing from this place a unit positive charge, then the potential at this point is VA. What is potential? Work done in bringing a unit positive charge from infinity to a point is the potential at that point. Okay, so suppose तुमने Q charge लाने के लिए WA काउंट किया. So what is VA? WA by Q, right? And to bring it here, you did the same charge at this point. You did what? WB. So what is VB? It is okay. So it's the way you define it. It's a reference definition, right? So what is potential difference between this A and B? Potential difference between A and B is VA minus VB. Which work is greater? To bring the charge from infinity to A, more work done, no? This extra work is done. So how much is this now? Okay. How much is this? One cube. Correct? And what is this? Work done in bringing the charge from B to A. That's what we define potential differences. Because this is common work no, for both A and B. So more practical definition is potential difference, not potential. In real life, we move the charge between 2 points. And this is for creating the definition of potential difference. We define what is electric potential. Some destination से लेके आ रहे charge. Like cell में terminal पे charge कहाँ से लेके आ रहे electrolyte से? वो infinity हो गया. वहाँ से लेके आके जब तक दोनों electrolyte पे potential difference create नहीं होता है, तब तक practically useful नहीं हो. So this is not a practically useful definition, but potential difference is. What is V? Potential difference. Okay, so V is potential difference between 2 points. Between 2 points. A and B. समझ आ गया? So you might as well draw this diagram and write down. Potential difference is practically more meaningful. Now those who have missed today's lecture, this vacuum is going to remain bold. Potential क्या होता है? Potential difference क्या होता है? There is very subtle difference, not much. So potential is only used to define. Like A, B, C, D individually has no meaning. Word has a meaning. Sentences has a meaning. You understand? So potential difference has practical meaning. Just A, B, C, D are symbols. So electric potential is symbol to define potential difference. Logically speaking. Just like in scale, why do we use scale? To measure length. Okay. Does this 1 centimeter has any meaning unless we know where the zero is? So zero is the reference. Just like that, for this potential difference, we need to know what is potential at A, potential at B. It's a reference definition. That's it. Anyway, so don't bother much right now. If you have understood what is potential difference in terms of work done, that's good enough. All the questions will be asked on this WIQ. Okay. When did we start the lecture?
11.
11. So it will go on till 12:30.
Yes.
Sure. So let's do some revisions. So if you have NCRT, there are some solved examples and in-text questions. Do you have NCRT? एक मिनट में देखता हूँ उसमें भी सेम क्वेश्चन थे. Okay, look at example 11.1. Same question. What is given? So far, how many formulas we have learned? We have learned formulas so far. So what are the formulas we have learned? V is equal to W by Q. Second is current is equal to Q by T.
Q is equal to AT.
And Q is equal to
NE.
ठीक है, अभी तक हमने 3 फॉर्मूले देखे. तो अब यही क्वेश्चन करना है. देखो, व्हाट इज क्वेश्चन 1? A current of 0.5 ampere is drawn by a filament of electric bulb for 10 minutes. So given I is equal to 0.5 ampere, T is equal to 10 minutes, which is how much? 60 into 10, 600 seconds. Find the amount of electric charge that flow through the circuit. You will find N equal to what? No, electric charge Q equal to what? So what is the formula that relates all this? I is equal to Q by T. Q is equal to I into T.
But the small plant, the capital you are saying.
Invariably. Actually Q for bigger charge. Okay? What do चलता है? उससे भी बात करो. You can write capital Q also if you want. ठीक है? तो I into T. 6. So how much is this? Now this is a very big charge. 300 coulomb. 1 coulomb itself is billion times billions. Right? And times 6.25. Okay. Okay, next is how much work is done in moving a charge of 2 coulomb across 2 points having potential difference of 12 volt. So work is Q into V. Since V is equal to W by Q, this gives you W is equal to QE. So 2 coulomb and voltage is 12. So 24 joule. Right? So if you have NCERT textbook, now open that. We will discuss some in-text question. So first is what does an electric circuit mean? Already written closed, continuous, conducting path, current conducting path. Okay, closed and continuous current conducting path. Define the unit of current. What is unit of current? 1 ampere. Means you have to define what is 1 ampere. Okay, so you can define. How can you define?
1 ampere is the amount of current when 1 coulomb of charge flows through an electric circuit every second.
Very good. Okay, that's what it is. So think of a mathematical definition, put it in words. That's what you do. Calculate the number of electrons constituting 1 coulomb of charge. And you can calculate because Q is equal to NE, therefore N is equal to Q by E. Q is 1 coulomb and E is 1.6 into 10 raised to 19 coulomb. That's all. Okay, so we have already done this. Name a device that helps to maintain a potential difference across the conductor. Cell. Okay? So name a device that helps to maintain a potential difference across a conductor. Cell or battery also. Second, what is meant by saying that potential difference between 2 points is 1 volt? This is like define what is 1 volt. Okay. What is meant by saying that potential difference between 2 points is 1 volt? What is 1 volt? W by Q. 1 volt is 1 joule by 1 coulomb. Put it in English. When work done in moving 1 coulomb of charge between those 2 points is 1 joule, then potential difference is 1 volt. Okay? Think mathematically, convert in English. How much energy is given to each coulomb of charge passing through 6-volt battery? How much energy is given to each coulomb of charge passing through a 6-volt battery? Write down the question. How much energy is given to each coulomb of charge passing through 6-volt battery?
6 volt, 6 volt.
Given to each coulomb of charge passing through a 6-volt battery. It is in the textbook near you. Don't say the answer, only raise your hands. Yes. So one raise. Okay, put it down. Show me your notebook.
Yes, sir.
So cell say how much charge is drawn? 1 coulomb. What is the potential difference of the cell? 6 volt. So, just raise your hand. Done? So, question asked is how much energy six coulomb. Energy. That's right. Right. What's the unit? 6 joule. So what is V? V is W by Q. Now, work. What is the unit of work? Joule. What is the unit of energy? Joule. So, cell is doing work. Okay, in moving the charge. Moving charges has kinetic energy. From where they got the energy? From the work by cell. So, work and energy are two faces of the same coin. Okay, when you are asked energy, you have to actually calculate in terms of work. Because whenever work is done, energy is spent. And both the units are same. Work is also joule, energy is also. So what is it? What is the answer now? So this is 1 into 6. So क्या आएगा? 6. Okay, so this is where they catch you. मतलब energy and work play करते हो. ठीक है? So you don't have to get confused. Go by unit. Whenever in confusion, go by units. Okay. So we have already done the circuit diagram, right? Now we'll discuss the symbols used in circuit diagram. So we will now draw a circuit diagram which uses almost all the symbols. Okay, so almost all the symbols we will use now. So this is E, this is battery. This is R, this is the rheostat. Okay, now we'll discuss all the symbols. So what is the first symbol? This is cell, when it is only one. When you use two or more than two. This is battery. This combination of two or more cells. Okay, then we have so this is when there is no dot, it is called open key. Right? It is also used like this. This is also, there is another symbol for open key. Key open like this. Hold, four, closed. Key. Closed open key is like switch off. It is not a continuous, closed and continuous path hona chahiye. It is open. So it is not continuous, okay? What about this? Switch on. There is one more symbol for this. Okay, then we have wire joint. In wire joint. So how many joints are here? We can show joints here. Okay. So wherever you have joints means all of these devices require two connections on both sides. One this side, one this side. Okay. These are wire joint. In between you have connecting wires. So wire is not joined, then it will jump. Wire crossing. without joining. So this is all done. This jumping. There is no connection. Wire is crossing over. Electric bulb. How the electric bulb is shown? Like this. Okay, register. Register of resistance R. So this is register, the symbol of device. Its value is R. It is given in ohms. That will listen. Here are two separate, similar, two different categories. Variable resistance or rheostat. This is fixed resistance. A fixed resistance. This is now variable resistance. Or rheostat. So when you put an arrow like this, then it becomes variable. This is also rheostat. Okay. So where is the rheostat used? Here. Like what is the example of variable resistance in our daily life? Yes. We use resistance to control the flow of current, increase or decrease, right? So when we are using highest speed, we are using maximum current. That means for highest speed, we are using least resistance. Okay, we are using full current. Like this is like friction in case of electricity. It opposes the flow of current. Just like friction opposes the motion. So to regulate current, we require rheostat. Okay, we'll see it in more detail later. Now, you have ammeter. What is ammeter?
It measures current.
Yes, ampere meter. In short, ammeter. So ammeter will be used to measure current. So ammeter is connected in series. You see, it is connected in the circuit. So series, in series. All is connected in series. Okay. And how do you connect voltmeter?
In parallel.
In parallel. Voltmeter. The symbol for voltmeter is this. Connected in parallel. So what is parallel connection? Therefore, you have the device and you are connecting it across the device. So it becomes parallel to the device, across the device. Whereas this is connected next to the device, so it is in series. Okay? So it is just the way it is connected. So as the name suggests, how to measure potential difference in the circuit? You have to use a voltmeter. Okay? So electrician generally roams with all these gadgets. You will have voltmeter, you will also have current meter, right? Multimeter होता है आजकल तो digital आता है. इतना ज़्यादा it will be displayed. Okay. So we'll see all of this when right, I'm back after the break. After the break, we'll see all that. Then we'll cover Ohm's law, series and current. There is one more right now. It's called galvanometer. Galvanometer. What is it? So it is just G. So what does it do? It just detects the presence and direction. So all this we'll see on the net with images and all.
तो मैंने ऐसे ही किया
आयन के लिए
मैं करो आयन के पैटर्न
ये देखो ये भी है ये भी है सुन और चीजें ये बस हेल्प के लिए है इसका फोन
दोनों आयन के पैटर्न रखते हैं
इन वो सब के लिए दो चीजें हैं आगे का अब बिल्ली है एक डाल
चलो सर
जब याद है बंदे को भी बहुत पता नहीं अगर इधर है तो कोड इधर है तो भी कोड किसी इधर से दूर जाए
एक काम करो इंग्लिश से चीज अपना टाइम पे इंग्लिश से बात करते
फोन रखो बैग में क्लास में यूज नहीं करना है फोन